Back to IoT series. In this video, we'll be looking into interoperability chapter. So we'll be covering all the important aspects of this particular topic. So let's start by understanding what interoperability is actually. So when we are combining two or more devices, two or more systems, and we are making sure that they are communicating with each other, exchanging the data, and working properly, that is what is referred as interoperability. So understanding the definition here, it refers to ability of different systems, hardware, middleware to seamlessly communicate, exchange data and share services regardless of their manufacturer model or platform. So the need of interoperability is growing as more and more manufacturers are developing and developers are creating the IoT devices. Considering this as an IoT deployment environment, IoT deploying environment. So here we have the PCs, and on the other hand we have the smartphones. So when we are establishing a communication between these two devices, it could be termed as interoperability. But these are like proper devices. But then when we come to small sensors and processors, is it are they that advanced, or do they have sufficient technology to establish communication? No, they don't have it, right? So in that case, interoperability plays a very important role from IoT perspective. Necessity of interoperable solutions in IoT arises due to several factors. First one is large scale cooperation. That is, when we want to combine multiple devices, there are multiple systems, IoT devices, large number of devices. Combining them would become a very big problem if they are not interoperable properly. Then global heterogeneity. That is, there are multiple IoT networks which we know. Some are small, some are big, some are very complex, some are very simple. So it is very important to make sure that all those are able to connect together properly. So the ultimately of each and every IoT deployment environment, the main aim is to perform whatever the actuator operation is there, right? So in order to achieve that, interoperability plays a very important role. Unknown IoT device configuration. So the configuration of IoT device can vary greatly in terms of data rates, frequencies, protocols, language, and syntax, requiring interoperable solutions. Only when there are standard solutions, that's when we can connect two extreme sensors or two extreme IoT devices. Let's take the hydraulic sensor and connecting it with the rotor. In order to establish this connection, we should make use of interoperable solutions are very important. Then semantic conflicts. That is, because there are unknown IoT configurations, many devices present, even the configuration and processing logic also varies here. So it is very difficult to understand it if the logic is varying for each and every device. In that case, we require an interoperable solution. Then you have syntactic conflicts. That is, variations in syntax of data formats can cause problems. So in order to overcome these, we require interoperability. Network heterogeneity, that is, many different wired and wireless connectivity technologies are there, but then we require one technology which will accommodate all these sorts of problems, or which could be a solution to all these problems. That's when we come up with interoperability in IoT ecosystems. So this diagram, smart camera gateway is there, and here we have the aggregation server which will collect all the data and facilitate communication. It is here, it's mainly bi-directional. Okay, so we'll further speak about the heterogeneity in IoT devices and what are the differences which can arise. The first is communication protocols. There could be multiple protocols. It could be Zigbee, Bluetooth, Wi-Fi, low range, and multiple protocols are there. Right? Even the programming languages are many programming languages are there: JavaScript, Java, and so on. Hardware platforms, different components will require different hardware capacities. Some might require less memory, whereas some might require tons, like terabytes of memory, and so on. Right? Not just that, even the interface also varies here from camera to mobile. Even the operating system varies, and the database, different database systems are used here. Data is represented in various forms: CSV, text, RTF, OFD, strings, characters, and so on. We have control models. So different control models are used. It could be event driven, publish, subscribe, client, server, master, slave, and so on. So from all these differences only, heterogeneity in IoT actually happens. Speaking about the taxonomy of interoperability. So types of interoperability can be grouped as. So this is a very important question from exam perspective. So first one is device interoperability. That is, when the devices are varying, the functionalities of this device is varying. its hardware is varying, power is varying, and processing power is varying, requirements are varying, then it could be termed as device interoperability. Platform interoperability means we are addressing various variations in operating systems, data structures, and programming languages, and application development environments. What are the different platforms? Like operating system platforms only is one of the best examples to understand. Then we have semantic interoperability, that is, we allow the agents, applications, and services to share meaningful data without without providing any conflicts in the data models, information models, or ontologies. And then we have syntactic interoperability, that is to deal the conflicts between the different data formats, interfaces, and whatever the pre-existing schemas are there for those devices. Then we have network interoperability, that is wired network, wireless network, different protocols. Addressing all those problems, this network interoperability is standing ahead. Then looking at the standards, so because we are enabling interoperability, various technologies have been standardized, and it is very important to standardize technologies also, right? That's when all the devices can be under the same level and they can communicate or interact with each other properly. So this interoperability efforts worldwide across various industries, domains, and technologies. We have 7 popular standards here. Let's discuss these one by one. Okay. So the first one is EnOcean. EnOcean. Okay. So it's a wireless technology which is designed for building automation systems. A primary principle is energy harvesting. It is very robust, very popular, and it is used in industries, transportation, logistics, and homes. Speaking of features, first one is batteryless operation. So because we are speaking of energy harvesting, this particular technology should make use of very less power. So it makes use of ultra low power electronics with micro energy converters to enable wireless communication. So this will harvest energy from surroundings. It could be sun, or it could be electric, solar, and other forms. Then wireless communication again. So EnOcean devices such as sensors, switches, controllers, gateways can communicate wirelessly, and it makes use of standard technology. So these are the technologies, wireless technologies are used. Low data rates here, because we are speaking about the low power electronics, obviously the data rate or the amount of data or amount of packets which are being transferred are also less, thereby reducing the energy consumption. Here it's 14 bytes long. Okay, because we are dealing with the low energy devices, so even the energy consumption has to be very low. Speaking of the energy consumption here, it is only consumed during RF energy transfer of 1 second transmission in the binary encoded message. Then transmission frequencies, again transmission frequencies are 902 megahertz, 923.35 megahertz, 868 megahertz, and so on. Speaking of the range could be from 30 meters to 300 meters. That is in it is similar to a local area network. Okay. Then we have a maintenance free. There is less maintenance because it is very robust and scalable, which we have discussed in the starting itself. So here this figure will tell us about how the major constituents of EnOcean devices are. So we have the wireless module here firstly, and then we have the energy converter. So along with that we have energy management processor, RFID, RF transceiver, and then we have wireless system module here, and yeah, so wireless system module is there here. So all these devices makes use of low power consumption micro energy converters to enable wireless communication. So the self-powered nature of EnOcean devices make it very suitable for a variety of applications, and wherever battery concern is there, no, on those places we can make use of EnOcean. Primary principle is energy harvesting, which we have discussed. So we ensure that devices are self-powered and it requires very less maintenance. So they are widely used in logistics, transportation, home automation because of its reliability, low power consumption, and standardized nature. Next we have is DLNA. DLNA is Digital Living Network Alliance. Again, this is very important from exam perspective. So it is a standard that provides interoperability guides for digital media among the multimedia devices. Digital media will have all the photos, like videos, images, and so on, right? So in order to provide a standard guideline for all those, we make use of DLNA. So DLNA will create a consortium of consumer electronics. It was created by a consortium of consumer electronics in 2003. So it was also previously known as Digital Home Working Group, and now it is renamed to DLNA. So it is mainly designed for home networking and relies on wireless LAN area network connection. Next, we have the figure here, which is a representation of various roles of DLNA based streaming applications. We have here we have the DLNA media server. Here we have the streaming option. Here we have the media player, which is streaming. And once the digital media controller browses, then the streaming process happens. And along with, only when the request is raised, that's when the data is transferred. Firstly, interoperability. So DLNA will aim to enable seamless digital media sharing among the devices. It could be smartphones, smart TV, tablets, and any other thing. Home networking focus. It is basically designed for home network environment. And then we have wireless local area network compliance, or it works on this particular mode of communication. Then content prediction. So it includes digital rights management layer to allow sharing of multimedia data while preventing privacy. So it incorporates cable, satellite, and telecom service, providing ensured data transfer link protection at either end. So from security perspective, this is a very strong protocol. And then we have accessibility. So DLNA enables consumers to view subscribable content without additional add-ons. So it is accessible by everyone. Then we have global reach. As of 2019, billions of devices are adhered to DLNA guidelines. Speaking of the key technological components, first one we have is network and connectivity, which establishes how devices will connect and communicate. Then we have device and service discovery control, which will tell us how the devices and services are discovered in a particular network. Then we have media format and transport model. What are the formats of media which is there, and how is the data being transferred among each other? Then we have media management, distribution and control, which will tell us how the media is handled, distributed, and controlled. And then we have digital rights management and content protection, which is focused on protecting the content and managing the rights. Then we have manageability, which addresses the management of DLNA devices and networks in a given system. So typical DLNA based media streaming applications will involve these steps. Okay, first one is browsing. So a digital media controller sends a request. Then a DLNA media server will respond to this request, and after that it will play whatever the received stream is there should play. So it will allow interoperability of multiple media devices with a home network. It addresses the sharing of multimedia content between variety of consumer electronics while also protecting the digital rights. So we have discussed these points earlier. Next we have Konnex. So even this question was asked in internals. Again, a very important topic. So Konnex is a royalty-free open standard for home and building automation. So this is designed for the wired communication, whereas DLNA was mainly focused on wireless, right? So this is for the wired communication. So this is used in the building automation, controlling lights, doors, AC, security, audio video systems, energy, and so on. Key features is firstly it is wired communication. So it supports RF and IP based communication also. So although it supports that, but it is majorly wired communication. Okay. So it can be in order to establish the wired communication, either it could be the twisted pairs, or it could be the power lanes, or it could be the IP based connection. So it is royalty free, open standard. Anyone can download it and use it. Then building automation focus, it is mainly focused on building the automation tasks. Then distributed applications. So this is being widely used, as we have seen the applications in home automation. So many different systems, different applications are using this. Hardware support, it provides a support to the hardware. In order to connect all this, we have to make use of the microcontrollers and microprocessors, right? The Arduino boards or any other microcontrollers and processors. So it provides a great support also. Integration is also there with wired and wireless technologies both. Then addressing. So it makes use of 16-bit address bus, which can accommodate 57,375 devices. So from scalability perspective, this is very high and this is very robust, flexible, scalable. So like all these key points, they are very important, because once you write these key points, it becomes very easy to fill up the rest of the part, right? So here we have the figure which speaks about how the different components are connected to the Konnex network. So here we have the building network, and here we have all the smart appliances which are connected to the Konnex bus. So from this bus, wired communication again. So this is again connected to the server. So from this server, it is further connected to the internet, and it is connected to the gate through the gateway only. So here we have the sensors, which are the smart home appliances. So then we have the actuators. Actuators could include motors, switches, and other valves. and controllers are the gateways which are present here to implement the logic. Then we have system devices and components, which would be couplers and other system devices and components. And in order to establish this communication, we make use of twisted pair bus. So KNX also has different configuration modes based on their device categories. So a system interface component is used for loading application software like system topology and operating software onto the devices, which can then be accessed over the LAN or home networks. So this feature will allow us for centralized and distribution control of systems remotely. So KNX evolved from three previous standards. So it was BT bus and European Home Systems Protocol, and after that we had European Installation Bus EIB Instabus. So it is approved under this international standard. So if you remember this in exam, it's well and good. If not, you can leave it. Then we have a universal plug and pay. Again, this is important because it was asked in internals. So UPnP is a set of networking protocols which are designed for service discovery and establishment of network-based data sharing and communication of services. It is used to establish dynamic connections to the computing platforms. So you are plugging and then after that enabling the communication here. So protocols used, there are a set of protocols used, and we have devices like PC, printer, mobile device gateways are used for communication. Looking at the key aspects, first one is dynamic connectivity. That is, this UPnP protocol will allow devices to automatically configure and connect to each other, connect to the host. So establish working and configuration with other device when connected in a network. Service discovery. Whenever you are present in that network, if the devices are there, then they are identified then and there, and further the data communication and data sharing can happen properly. Zero configuration networks. So device can dynamically join the networks, obtain IP address, advertise their presence, detect other network devices through process of zero configuration. So we'll discuss the steps further. Then we have IP based. So it is designed to run on IP enabled networks. It makes use of HTTP protocol, and along with that even XML and SOAP are also used for the networking services data transfer to happen. Then multicast and unicast feature is available here. It is not just one way, it could be the multiple ways also. And here it is a open standard, that is, it is a distributed and open standard managed by the Open Connectivity Forum. The protocol stack will include HTTP-U, that is for discovery, HTTP-MU for discovery, but HTTP over UDP is used for multicast device to search the requests and advertisements. Then we have HTTP discovery, which is used for device discovery. Then we have SOAP, which is used for control purpose, and then we have JENA for event notification purpose. So these devices, they are typically categorized by control point and services. Services will communicate with the control point, and from there the further actions is happening. The control point can be used to control various services at home, various devices at home, and they can be like integrated together with UPnP services through a bridge. So UPnP will support a range of IP supporting media like Ethernet, IR, Bluetooth, Wi-Fi and others without the need for individual device drivers. So dynamic connection is establishing here, and if a DHCP server is not available, device can auto IP to assign themselves IP address. So again, auto configuration topic we have spoken, so it's the same here. So if you see the figure here, so the control point is there here. Control point will retrieve the device information through a local URL which is sent by the device. So the device information is further is present in the form of XML schema using SOAP in order to get control purpose, and it contains a list of services, what are the services to do, what are the commands, and what are the actions and parameters. So CP control point will make use of control messages to send necessary actions, and then take perform the various operations. So if a device has URL for presentation, then CP will retrieve the content, allowing the user to control or view the device and change its status also. So UPnP is designed for non-enterprise devices, and its scope includes discovery and intercommunication between network devices like these devices, mobiles, printers, access points, gateways, TV and other commercial systems with IP capability, Internet Protocol capability. The overhead and traffic generated by UPnP systems make it unsuitable for enterprise systems due to operational costs, because when you're deploying this technology, or when you're deploying this protocol over a large scale, there the problem of operation cost and the traffic and overhead comes. So in that case, we can make use of this protocol only in small scale applications like home automation and all of that. Next protocol which we have is LonWorks, that is local operating network. So this is a protocol which was developed by Eklon Corporation, which was designed for network control applications within the building. So it was very much specified for the application of buildings. So it uses physical communication, that is, it makes use of wired communication, including the twisted pair, fiber optic cable, power lines, and RF. So it was standardized by ANSI as LonTalk in 1999 for control networking. Speaking about the key characteristics, first is physical media. It makes use of physical wired communication. Then we have communication media, that is twisted pair cable. So twisted pair cable has a data rate of 78 kb per second, and then the power line is lower and depending on the line frequency. Then we have building automation. This was basically designed for the application in the buildings. And then we have backward compatibility, that is, it has IP based tunneling standard which supports, and it makes use of the legacy installations. So not just that, even the IP based services are made use here, provide support to this particular protocol. So guys, these points are very important. If you know these points, no physical media, you can cook up anything later, because this is a theory subject. If you know this point, you can further make a sentence very easily. Speaking from the applications perspective, include usage in the pneumatic brake systems of trains, that is to stop the trains depending on the little pressure you apply and the entire train gets stopped, right? So in that such applications, non-works play a major role. It is used in the semiconductor equipment manufacturing, in petrol station controls, and it is also used as building automation standard. Next we have neuron chips. So neuron chips can be told as the heart of non-work based applications or devices. So this neuron chip, no, it is like a complete system on a chip. So this neuron will contain the entire LonTalk protocol along with the memory, CPUs, IO devices, IO ports, communication ports, firmware, and a separate operating system. So it's like it is built on the LonTalk protocol, and it has a 8-bit processor, custom designed IC called as neuron chip. So we have system on chip, that is all the essential components are present inside this chip. Then there are two types of the neuron chips based on the memory and packaging capabilities, 3120 and 3150. Then speaking about the multiple CPUs, neuron chip will have 3 CPUs, one for the MAC processing, one for the network processing, and one for the application processing. Then this will handle the CRC checking, so cyclic redundancy check, to check if there are any errors occurring, and bit transmission, data transmission, and checking if from the sender side and receiver side if there are any errors or data is being manipulated or not. All that thing is done here. So message transmission, reception, and confirmation of message destinations is taken care. Then the network processor will deal with addressing, routing, acknowledgement, and other network layer tasks. Application processor is used for deploying the custom applications. Usage of these custom 8-bit operation, 8-bit processor into the actual environment, actual IoT environment, and usage of these in the day-to-day lives happen through the application processor. Speaking of the memory types, so each neuron chip will have 3 memory types: ROM, RAM, and EEPROM. So we know the definitions of these and how it works. So LonTalk protocol, OS, and IO libraries are typically programmed in ROM during the manufacturing. So this figure is representation of LonWorks network. So here we have all the wired communication which is helping to connect to the LonWorks controller. From this controller, it will be further transferred to the user interface. So next we have addressing. So each LonWorks node will have unique 48-bit address, which is analogous to the actual, the basic, or the standard Ethernet MAC address. So this works. So the LonWorks devices can have up to 63 logical addresses. So these are used for the logical groups, network segments, which will help us to segregate from their 48-bit addresses, node addresses. So this is a very robust and established technology which is used for control networking, and it has a wide range of applications. That's what we have discussed above. So the applications range from the petrol station controls, semiconductor equipment manufacturing, building automation standard, braking systems for the trains, and so on. Have is Insteon. So Insteon is a very popular home automation and lighting technology, home automation lighting technology, which was developed by Smart Labs in 2005. And this basically speaks of the interoperability and automation among the household devices by making use of RF and power line communication. Looking at the features, first one is it offers the dual band communication. It makes use of both RF and power line communication, wired communications, and here the frequencies are specified 131.65 kilohertz, while RF communication operates over frequency of 915 megahertz. It supports peer-to-peer communication, that is all the devices which are connected or all the Insteon connected devices acts as peers, and they can independently communicate with each other which are present in the network. So it has dual mesh network topology. So it makes use of dual mesh network topology, which thereby reduces all the interferences, and it reduces all the problems, and the transmission of data over the power line and vice versa happens efficiently. Addressing is Insteon networks can have more than 16 million unique IDs and support more than 65,000 devices. So it is very scalable, very flexible, and robust. Built-in engine, there is a built-in engine comprising of 80 bytes of RAM and 3 kilobytes of ROM, and application specific requirements may require additional RAM, ROM, or flash memory, and so on. Message handling happens through usage of the standard messages of 10 bytes or 24 bytes. So here each message can accommodate up to 14 bytes of user data, and 2 bytes have to be allotted for counting hops. There is feature of error detection here. So each device performs error detection and correction upon receiving the message, and if there is any error, retransmission of that message in order to send it again is sent back. Then from security aspect, so it has a robust firmware which prevents devices from forming connections until a bottom physically pressed on during the installation. Interoperability, so the legacy Insteon chipsets are interoperable with X10 power line messaging. X10 protocol will be studying it further. So reduced functionalities. Present day involves incorporated compatibility for certain functionalities of Insteon with Amazon Echo, Microsoft, Apple Watch, and Google owned Nest. So Insteon network communication has power line, which we have discussed. So it uses the BPSK, binary phase shift keying, with minimum receive signal of 10 MV. Then RF, it makes use of data rate. Here is 4.5 kilobytes per second, and here it is 120 range of 120 meter range without any obstructions. So looking at this figure, it represents the entire Insteon network where multiple devices are Insteon nodes are connected, and this will enable us to perform the peer-to-peer communication. There is a gateway, and here is the home automation. There is presence of one controller, meter is there, and a bridge is there to facilitate transportation of the signals to the gateways. From gateways, it is further transferred to the internet. So wherever it is wireless, wherever we see this signal, it is of RF they are making use, and for the wired communications we are making use of the power line. So these devices may include the lights, switches, thermostats, motion and gas sensors, and others. So all these are basically used in the home automation, right? And there is presence of dual mesh network, which makes sure that each and every device present inside the Insteon network connects to each other properly, and the communication happens seamlessly. There are central controllers which enable control through smartphone and tablets. So Insteon's approach to interoperability and its use of both power line and RF communication makes it a robust option for home automation. But lately, 2 years back in 2022 or 23, I guess, so this network or this standard was stopped. Like it's not there in the market now. So yeah, next protocol which we have is X10. X10 is again a communication protocol which was developed by the FICO Electronics in 1975, again for the home automation. So here it is only specific to the power lines, the wired communication. So this is one of the oldest and earliest home automation technologies which was invented, and it is still being used. Okay, let's look into the key aspects. First one is power line communication. So it makes use of electrical wiring to send the data between devices. Carrier frequency is the data is encoded over 120 kilohertz carrier frequency, which is transmitted during zero crossings of 50 to 60 hertz of AC signal. So this is the usual frequency on which the power lanes transfer the data, right? RF bursts, that is data and controls are encoded as brief RF bursts for signaling and control over power lines. Data transmission happens 1 bit per zero crossing. Addressing in X10 systems can have 256 possible addresses. So here each address is made up of 4-bit house address, that is from A to P, that option will be there. Then 4-bit of unit addresses, and then followed by that 4-bit of command. So multiple house addresses can be used with a single house simultaneously. Looking at the device types, we have one-way devices, which are typically cheap and they only receive commands. They cannot reciprocate it back or send the signals back. Two-way command is just opposite of that. Signal ranges, it is only restricted where power supply of house network or house or network using the inductive filters is taking place. Speaking of the signal transmission, so we make use of coupling capacitors or the active repeaters which are used for signal transmission over multi-phase system. Then speaking of the data rate, it is usually 20 bits per second, including the retransmission and control signals also. Speaking about the data frame, so each data frame is transmitted twice for reliable data transfer over any noisy channel. Command separation, so there is a new command which is separated by at least 6 clear zero crossings from the previous command, so that there is no confusion or mixing up of the previous commands. Then we have our RF protocol. So this protocol is defined under X10 to accommodate wireless remotes. When we are dealing with wireless communication or wireless components, here we'll be making use of RF protocol. So again, 310 megahertz channel in US and 433.92 megahertz in Europe is the operating uh, frequency. Then the wireless packets communicate to a radio receiver, which acts as a bridge between the wireless devices and power line devices. So we make use of the radio receivers here, which act as gateways to further transfer the data from wired to wireless communication. So if you see this figure here, it speaks about the representation of X10 network, where here if you see, this is a wired connection. Here also it's wired connection. Sensors are all wired connection. But then for the transceiver, it has to be over RF protocol, wireless communication. Okay. So data representation, a bit value of 1 is represented as 1 millisecond burst of 120 kilohertz at zero crossing followed by absence of pulse, and a bit value of 0 is represented as absence of 120 kilohertz burst at zero crossings followed by a pulse. Speaking of the functionality, due to its low data rates, they are kept very simple and they have limited functionalities, like either it's on or it's off. So this is a basic home automation technology. This laid the foundation for other home automation technologies to develop. So next will speak about the frameworks. Okay. So similar to standards, the interoperability frameworks have been into existence. So they span across different platforms, devices, technologies, and application areas. In this video, we'll be speaking about the 5 most popular interoperability frameworks. So the first one is Universal AAL. So this is an open source software framework which was designed for runtime support in the distributed service oriented environment, mainly focusing on the systems of systems. So the main idea or the ideology here is to provide semantic interoperability by sharing compatible models or ontologies with service consumers such as mobile devices and embedded systems. So this was basically designed for the compatible models, enabling the semantic interoperability. Speaking of the architecture, the platform is formed by different managers and middleware. So managers are any low level applications which provide the functional APIs, while speaking of the hardware, they are connected to exporters which are specific to technologies, like it could be Zigbee or Konnex technology. Middleware will coordinate the peer-to-peer layout called use space. Then you have a container which will support the middleware as well as the code. So the peering part handles the middleware, and communication and interconnections are also handled here. The UPnP like connector discovers the universal AAL nodes here and facilitates the multi-technology bridging. Speaking of the communication, so we have semantic information flow, which makes use of specific buses, like irrespective of the devices or network. Just to transport the data, we make use of the semantic specific buses here. So these buses are defined for context, services, and user interaction, strategy handling and semantics, peer matching, and many others. So we spoke about the use space here, right? So use space handles communication across different use spaces by managing the message exchange and authentication. So the main focus here is of this framework is human centric or user centric, focusing on enabling communication irrespective of which device, which technology, or which network you are using. So irrespective of all these components, all these factors, you are enabling the communication, and such framework is the universal AAL framework. Next we have is Alljohn framework. So Alljohn framework is an open source framework, so that allows devices within its framework to communicate with each other in that vicinity. So it's like the proximity sort of communication which is happening. So if you are present in the vicinity, the communication can happen here. It could also include the cloud connectivity. So it was developed in 2011 by Qualcomm, and it was later transferred to Linux Foundation under All Seen Alliance. So it was formed to promote the IoT interoperability. In 2016, it was merged with IoTVT, and it joined the Open Connectivity Forum (OCF). Speaking of the functionalities, so the software framework and core components will discover, communicate, and collaborate irrespective of the platform, band, or connection types. So this also has limitations of collaborating with different brands. Speaking of communication, which happens mostly through the Wi-Fi, and it will help us to connect the devices like smart home, smart TVs, smart audio gateways, and automotive devices. Speaking of the model here, it works on the client server model where there are consumers. Consumers are the clients and servers are the producers. So each producer is characterized by an introspection file which comprise of XML schema of the producer's capabilities and functionalities. Speaking of the services, it offers core services like onboarding, configuration, notification, control panel, and common device model service. And the technology used here is dbus message. The framework uses dbus message bus to create the dynamic proximal networks. And then we have IoTVT. So IoTVT is an open source project which was sponsored by OSF, and it is hosted by the Linux Foundation. It aims to unify, combine billions of IoT devices, both wired and non-wired, across the internet. So it is very compatible, it is interoperable and backward compatible with the Allison. And speaking of the scope, so the framework can connect devices across various profiles, including the consumer, health, enterprise, industrial, and automotive industries. The technology, it makes use of COAP protocol here at the application layer, and it's is not concerned with the physical layer requirements of devices, because at times it could be wired or at times it could be wireless. But from the application perspective, COAP protocol is used. Connectivity technologies could be Wi-Fi, Ethernet, Bluetooth Low Energy, Thread, Z-Wave, Zigbee, or any other legacy standards. Functionalities are, it supports core functionalities like data, device discovery, data transmission, device management, and data management. Next we have is Brillo and Weave. So Brillo is an operating system for IoT devices which was developed by Google. So considered a lightweight version of Android. And Weave is the communication layer for Brillo. So the Brillo is Wi-Fi and BLE enabled and is working to add other low powered solutions like Thread. Speaking from the interoperability, this framework extends the interoperability among devices and platforms from different vendors. Speaking of the Weave layer, it provides common language for devices to communicate with each other and with the cloud. So it's a information schema that defines the device types, functionalities, and mode of communication. So Weave devices either use the TCP or UDP protocol, and they are compatible with IPv6 or IPv4. Speaking of the components, there are main four modules: security manager, exchange manager, message layer, and fabric state. So functionality is, it will provide core functionalities like the bulk data exchange, common system status and error reports, data management, network connectivity testing, security, secure service directory, and many others. Next, the final protocol which we have is standard which we have is HomeKit. HomeKit is a software framework which was designed by Apple to work with iOS mobile operating system for achieving the centralized device integration and control framework. So it enables device configuration, communication, control of smart home appliances, allowing for home automation by incorporating the room designs, items, and actions within the HomeKit service. So this is like a complete framework which is provided in order to inculcate it with the Apple devices or the iOS devices. So users can interact using the voice commands here through Siri or any other external apps. Connectivity is in this HomeKit device, no, in this HomeKit service, there will be a hub provided which could be connected either using the Bluetooth or Wi-Fi. Speaking of integration, the non-HomeKit devices can gain benefits through the usage of HomeKit gateways and hubs. So these gateways and hubs acts as the central server or the central communication platform which will connect it to the HomeKit devices. Then we have security. So HomeKit enabled device manufacturers need to have MFI program, and all devices were initially required to have encryption coprocessor. So this MFI program and the encryption coprocessor will help to maintain the security. So this was all about the HomeKit. So this was a brief summary of all the frameworks. So here each of these frameworks will aim to address a particular challenge of interoperability in different ways with varying focus and technical approaches. So in this video, we have covered all the major topics of interoperability. If you have any doubts, do let me know in the comments, and stay tuned. I'll be uploading other videos pretty soon. Yeah. Yes, thank you.